Dear students, today's topic is exclusive OR gate. The topic code is ELEC-DIGIE-S3C. Now, the exclusive OR gate, the exclusive OR logic or function is a very useful circuit that can be used in many different types of the computational circuit. This is typical the symbolically we have an OR gate and another at the base of this OR gate. We put another small curved line is a little distance away. We have got the two inputs and one output. Exclusive OR gate. This is the Boolean expression or the logic equation. This is the representation, like a OR gate is represented a plus b. So here the exclusive OR gate is represented by a plus encircled b. Okay, so this is exclusive OR gate. The a and b both two are here related with the exclusive OR operation. This is the logical expression, that is a complement and b complement is a dot product, and b plus a dot b complement. So this is we will see in a moment with the truth table that this give rise the exclusive OR operations. So this is the equivalent circuit diagram. If we apply this, we have got a and b two inputs. When we give that, we can also get the equivalent a plus a or b dot a and b complement. This is another way we can represent the same this equation term, or we can have a complement gate and b, or the addition of these two. So we can represent that as well. So in this case, what we have, the a is OR gate OR option, and we will be doing this in the next coming logic gates as well. We have how the gates are interconnected together. So we have an AND gate over here, a dot b, which is the complemented, and both of them are then fed to the AND gate. Okay, this is the OR gate going into the first input of the AND gate, so that is the AND operation. Okay, this is input 1 and this is the second combined input. Okay, we'll treat it as a single input. Output of this circuit is a dot b complement. Here we have a or b. This operator, AND gate operator, makes this a or b dot complement. Okay, here we have, this is the one of the, as I told you, we'll be discussing that in the De Morgan's theorem, which will coming later. We can apply by De Morgan's theorem and we'll get this result. But in order to this display show that this particular logical expression in terms of the gates, let me show you the same other form. This is the same. This is the logical equation basic, which is the expression for the exclusive OR gate. So here we got two inputs, a and b. We put a NOT gate in front of it. Here what the logical expression says, that we put over here the a complement, that is the a dot b. We need a complement, so we make first a complement. So a into inverter or NOT gate makes a complement. Then we need a b, so b is directly connected over here, the b. So a and b both are then fed into an AND gate. So AND gate is connected because a dot b, we have a dot b, which is AND gate. So we have connected an AND gate which gives the output, single output, which is a complement dot b, this here. Similarly, the other gate, which is a dot b complement. So in this case, now we give directly a from here to the input. A is being fed over here. So here what we have got, the a from here directly is a simple a input, and the b complement, we again place a NOT gate in front of the b, which gives a b complement, and then again we put an AND gate. So a and b, this is a dot a and b complement we got over here. Now both of these two are connected this is AND gate, this is another AND gate, then they are interconnected through the OR gate. So put an OR gate and feed to the two inputs. This is the first input, this is the second input from this side, and second from this side. What we get, the net resultant exclusive OR gate, which is A complement dot B plus A dot B complement, A exclusive OR gate exclusive OR B is equal to this logical expression. Now look at here the truth table for it. Very interesting the result we get. If you use this logical expression, you see here, whatever you put value of B, which in this case is B is 0 0 1 1, A is 0 1 0. So what we get here, the Q, which is the output, is 0 1 1 0. So if you see here, the two true output are when the both of our input are unequal. B is here 0, A is 1, B is 1, and the A is 0. So it is also known as inequality detector. What it is known as? Inequality detector. So exclusive OR gate is also termed as inequality. That inputs are unequal, then output is 1. So you see, if the inputs are equal, 0 0 and 1 1, output is 0. So this is also known as the inequality detector. Inputs are the unequal. Now here is these gates are then packed, are the fabricated in terms of an IC. IC is an integrated circuit where a large number of the electronic components are packed inside, and they perform a certain logical operations. This is a particular IC 7486 quad. There are two types of TTL, and the other one is the CMOS. Two types of ICs are there. So you can see this is called the quad exclusive OR gate. Quad 2 input. So there are 4. Quad means 4 exclusive OR gates connected. In this case, here is a notch. From the top view, or we can see here, we can have the pins. There are 14 pin ICs, 1 2 3 4 5 6 7, and then we move 7 8 9 10 11 12 13 14 pin ICs. Out of these 14, 2 pins are used for the VCC voltage with the positive VCC here. The 14th pin 14 is connected, and the ground is the pin 7. While then other are, this is the gate 1, the exclusive OR gate 1, A1 B1, input 1, input 2, input 3, input 4. 4 inputs of each A's and B's are fed, and the 4 outputs Q1 Q2 Q3 Q4 are obtained. So it's a very useful exclusive OR gate IC is used in electronic circuitries. So we move to the next now type, which is now exclusive NOR gate. Exclusive NOR gate function is a digital logic gate that is reverse or the complementary form of the exclusive OR gate. It is just simply we put a bubble sign to it, and it is converted exclusive OR to the exclusive OR. It is then termed as exclusive OR gate. You just exclusive OR, and the complement we put, then we get the exclusive OR gate. We get the exclusive NOR gate. Sorry. This is the logical expression A and B, or A complement and B complement. AB plus A complement dot B complement. So if we put here, this is exclusive OR gate, exclusive NOR gate, exclusive NOR gate equivalent. This is exclusive OR gate, and we put a NOT gate to it. Then this is Q A exclusive RB complement. That is, and this is the equivalent circuit diagram again for this that this particular here is a particular that obviously we have two AB. This is the AND gate. A and B are fed. We get AB. Then we need two A complement, then A complement B complement inputs, and we put an A complement here, the NOT gate, which is A complement. We put another NOT gate, which is B complement. Then we get an AND gate, which is the A complement B complement. This is the, then we both of these output of these two gates, AND gates, is fed to the OR gate, which is this one OR gate. So A B into this input of the OR gate, and A complement dot B complement into the input, second input of the OR gate, we get resultant Q, the output which is A and B, or A complement and B complement. So this is the logical expression. Now here what we see that the truth table, if you look at if you put these values in this expression, you will get this result. So what we see here, again a unique thing, is that the output is 1 if both of the inputs are equal. A is 0, B is 0, here B is 1, A is 1. So it is also called equality detector. Okay, so the exclusive NOR gate is also termed as equality detector, and it is used in the electronic circuitries. Very useful applications are over there are found with the help of this. This is a universal gate. This is also a universal gate, just like a NAND gate is a universal gate, and we can have NOR gate and the NAND gate are the universal gates, but it's this is not a universal gate, but it is applications are used in a universally in various electronic component circuits. So that is the if inputs are unequal, the output is 0, but if inputs are equal, then output is 1. So this is the also the typical type, the 74266 quad 2 input exclusive NOR gate IC. Again, you can see 4 NOR gates are there, each having 2 inputs, A1 B1, A2 B2, and A3 B3, and so on and so forth. So outputs, 4 outputs, Q1 Q2 Q3 Q4, VCC and ground are connected to the 14 and the 7 pins respectively. Okay, with this we reach to the end of this topic. Thank you very much for watching the video. See you next time. Goodbye.